Hello friends, and in the continuation I'm going to solve the third number question of the chapter first of the communication system that has been taken from the previous gate exam questions, and here is the question on your screen. So this is 1.3, and the reference again I am telling you that the reference that I am taking is Made Easy previous year gate question bank, and in that communication subject I have chosen, and I will solve each and every question of that communication system in the continued lectures. And in this lecture, I am going to solve the third number question of the first chapter of that question bank. Okay. So the question can be read as which of the following schemes suffers from the threshold effect? Okay. So here we will have to first understand what is threshold effect first, and then we will check for which of the following four options that is given here threshold effect applies. Okay, so first of all, threshold effect is what? Actually, threshold effect is defined as the threshold point up to which up to which the signal detected perfectly, you can say signal detected perfectly, signal, or you can say signal correctly detected at the output. Means this is the case of the demodulator. Actually, any type of demodulator or detector can be there. Either it is case of FM demodulator, or you can say AM system demodulator, or SSB system demodulator. Any type of demodulator will may be there. So for which of these demodulators and which type of demodulators this threshold effect is defined? Means there will be some SNR level. Actually, SNR, first of all we must understand what is SNR: signal to noise ratio. It is signal to noise ratio. So if signal will be more, noise will be less, then it is a good system. Means if SNR will be very high, then for that case the system will be perfectly detected at the output. But in some cases there is some threshold point is given for SNR, that up to this SNR, means up to this threshold of SNR, the signal can be detected perfectly or demodulated perfectly. Otherwise, if SNR becomes less than that threshold, then in that case it will not be detected. It will not be detected. Okay. So overall, we got the point that threshold is basically defined for SNR. Okay, means SNR threshold effect, you can say. If SNR of a received signal is more than this SNR threshold, then in that case demodulation will be done correctly. But if SNR of the system is less than this threshold value, then in that case demodulation cannot be done. Overall, we have to study one by one all these systems and understand why SNR is not, means threshold is there, or why threshold is not there. Okay, so I have taken others that in other slides. Okay, in the second slide I am going to introduce AM detection, AM detection using envelope, or you can say envelope detection of AM. Okay, so in envelope detection, basically what is done? Basically, in envelope detection, we used to see like this: AC plus MT cos omega CT is the signal, modulated signal, of course we have, and we want to remove this cos omega CT, and we want to get this one MT. So basically, what is done in envelope detection? The average value is taken out. Means of course average value will be what? Average value will be like AC cos omega CT will be taken out, and after applying with its on RC, you can say at output there will be RC signal, and here will be a diode in envelope detector. Okay, so overall the average signal will be removed from this you can say modulated signal, and then we will get at the output the desired signal, that is empty. Now we are concerned not about the envelope detector. I will explain it in some other slide. Of if some question appears related to the envelope detection, then I will explain in detail about envelope detection. Here the concern is about SNR, and we are seeing it only. Okay, so here we can see that the envelope detector is assumed to be SE coupled, so that y dt means output of the detector will be like this. If there is a received signal RT, then its average will be decoupled from it, means average received signal will be taken out, the rest will be taken at the output, and that will give the message signal. Okay, so in this received signal we will have, the modulated signal, means AM signal, plus some noise also will be there. Okay, so that noise we can consider here, means actually the complete formula is not given. So this type of formula means this will be the message signal, means you can say modulated signal, plus there will be some noise, NT, you can say noise, and noise will have two components, means can be you can say further derived into two components. That one will be in phase component, means which will have the NCT cos omega CT component, and other will be quadrature component, NCT sin omega CT, means perpendicular to, means 90 degree out of phase to that one. Okay, so overall what we will get here, if SNR is more, it means signal is more than noise. Okay, much larger than noise, means this signal, means modulated signal, will be larger than, very larger than this NT. Okay, so if this signal will be very larger than the NT, then approximately, if we will add these two, means we will add this signal to this noise, then approximately the complete value will tend towards this AC plus MT cos omega CT, and there will be no any effect in this signal if SNR is very high. But when we will take the case of SNR is very less, which is explained in the next slide. Okay, so here is the next slide, and here we can see that when the noise will be much more, then the final received signal can be represented like this, means instead of if I am taking the entire AC plus MT cos omega CT like this, okay, in some direction, you can say phasor diagram I am showing. Okay, so and I'm you can say the components of the noise signal can be represented like this: NCT in this direction and NST in this direction, means in phase component and the quadrature component on perpendicular direction. So overall we can see that NCT will be added with this. Okay, so if this signal is very large as compared to the NT, then of course the addition will be also very large, means this component will be very large as compared to this perpendicular component. So overall the resultant of these two will tend towards this, means overall the entire component will towards this. But and in that case we have seen that there will be no effect of the noise in the after detection. But when we will consider the case that when NST is considerable, you can say NT is comparable with the signal, means NT is approximately equal, or you can say NT is more than signal, then in that case what will happen, this component will lead and this component will be very less. So overall the entire resultant will tend to this final result, or you can say resultant will be somehow here at phi angle something. Okay, so overall we will have some resultant which will depend on noise rather than the input signal. Means if that will depend on the noise, then we can write the entire received signal like this: cos phi and t is the component, it is multiplied with the AC 1 plus AM and T. Okay, so cos phi and t is basically, it is the component which depends on the noise. So overall we understood that when SNR is very less, then in that case it will depend on the noise, means the detected signal will depend on the noise rather than the signal, and overall we cannot detect the signal properly, or you can say there will be the loss of the signal, and this loss of the signal is called actually the threshold effect. Here it is written, the severe loss of signal at low input SNR is known as the threshold effect. So overall we understood that threshold effect is found in envelope detection of AM amplitude modulated system. Now we will see for discriminator, means frequency modulation as well, that there also threshold effect exists. So threshold and threshold extension in FM, you can say. So the very first line somewhere it was written in this book itself. It's in the book that I am referring here is Zimmer. You can read that book or purchase that book from anywhere. So okay. Threshold effect in FM discriminator. Again, similar to the case, the envelope detection we have just read out. So in the similar to the case here, we can see that when we are talking about the FM signal, then there will be signal like this. Means this is actually the modulated signal, FM signal, and this is in phase and quadrature components of the noise. Okay, so what we can see, omega ct plus theta, this will include actually the message signal as well. Okay, so if we further approximate the entire signal, then the approximation will be like this, and here is the theta. So if we will try to discriminate it, means differentiate it, then after differentiation we will get some component related to theta and upside t, means there will be some message signal plus noise as well in the discriminator part. And in the same manner we can further explain that if we are talking about SNR very very high, then in that case the message signal will of course lead, I mean will be much higher amplitude than the noise, and in that case if we are talking about the quadrature and the in phase component, then the message signal, the entire signal or resultant will tend towards the message signal, and there will be very less effect of this noise, and a signal will not be lost. But when we are talking that SNR is very very less, then in that case noise will be more, and of course the final result will depend upon the two components, means noise as well as signal, and that in that case it will become comparable, and overall we can see that there will be means in FM as well there will be some SNR threshold value, that up to this SNR threshold value, means if the SNR is more than this SNR threshold, then we can detect the you can say we can detect the FM signal very well at discriminator end. But if SNR is less than this SNR threshold value, then it cannot be detected. Overall, the SNR, or you can say threshold detection, means threshold effect, is found in both AM system, means AM envelope detection only, not in the coherent detection or synchronous detection, you can say. So in synchronous detection, basically we multiply the given signal with cos omega ct, and means similar to the message signal, or you can say carrier signal, and that is used to be removed. Here we do not use any, you can say, decoupling of the average signal. So that type of situation not occur in the synchronous detection. Means synchronous detection threshold is not found, but threshold effect is found here in FM detection using a discriminator, as well as AM detection using envelope detection. So A and C both options are correct, but in some book and even in MyDZ I have found the answer only C. So I am not agree with that answer. There it must be you can say multiple answers. And here also in the option in the question we are seeing that schemes suffer and as is written, means it can have more than one answer. Okay, so A and C are the two correct answers for this question. Earlier maybe it would be asked in GATE exam, two questions would options would be correct. So overall, threshold effect is or you can say threshold effect occur in AM detection as well as FM detection. In AM detection only in envelope detection technique, and FM detection in discriminator technique. So this was all about the question 1.3 of the communication system. I will come with the next question 1.4 in the next slide or next video, you can say. Thank you so much for watching.